Alright, so here's number 8. It says a ball is thrown upward at an angle of 30 degrees to the horizontal and it lands on the top edge of a building that is 20 meters away. The top edge is 5 meters above the throwing point. What is the minimum speed that the ball was thrown? Well, I've already got a picture here drawn. If you haven't drawn a picture yet, you should have done that. If not, try to cover it up, see if you can draw the picture there. One of the things I want to point out is that because of this word right here, minimum speed, it's important that we know that if it's at a minimum speed, if it goes more than the minimum, then the path of the ball is going to look like this. It's going to go way up and above it. But minimum is going to be just barely reaching the top of the building. If it's anything less than the minimum speed, it's going to smack into the building and then fall down. So that means that if I have a parabola here, we're talking about the vertex of the parabola. So I want you to think about what that means. What variable does that give you here? Pause the video and write out your givens and your unknowns. Alright, so I'm assuming you paused it. You've got your attempt for the givens and unknowns made. And remember that right here at the very peak height, it's like you're standing on the ground and you're throwing a ball straight up in the air and then straight back down. It has a positive velocity on its way up, a negative velocity on the way down, but at the very peak it hits zero velocity in the y direction. The same thing's going on right here. It hits zero velocity in the y direction. So this tells me that the final velocity in the y direction is 0. Okay? So if I look back, this is what I got for our givens and our unknowns. I know that the final velocity in the y direction is 0. The acceleration in the y direction is -10. The delta y is +5. And I don't know delta t or the initial y velocity. Over here, I know the acceleration is 0. Because in the x velocity, when something's launched at an angle, the x velocity is the same if we ignore air resistance. And then the delta x right here is 20 meters. So the first thing I'm going to do over here is see if I can use what I've got in the y direction to find out my initial y velocity. So if we look at our kinematic equations now, I know that the final velocity in the y direction is 0. I don't know the initial y velocity, but I know acceleration and I know my displacement. Now remember, this equation was written in our prior chapter. We only had one dimension, and that was usually in the x. But I'm going to change all of these to say a y. So for this equation, since I'm talking about the y direction, I'm just going to put a y with all those and change this to delta y, and boom, we've got our equation for what we need to solve this. The final velocity in the y direction is 0. The initial velocity we don't know, so it's going to be VIY squared, plus the acceleration, which is -10, times delta y, which is 5 meters. So 5 times -10 gives me a -50. Add that to both sides. We'll continue it up here. You get 50 is equal to the initial y velocity squared. Square root both sides, and the square root of 50 should give you 7 point something. Gives me 7.07. And this is in meters per second. That is my velocity in the y direction. So let's go back and write that in. 7.07 meters per second. Now I can solve for delta t pretty easily here. So let's see how long this thing is in the air. Just going to clear out everything that we've got. So pause the video if you need to write all this down. If not, I'm going to clear it out right now. Oops. Change the cursor on me. So I've got enough to figure out delta t using VVAT. So the final velocity in the y direction I know, initial velocity in the y direction I know, acceleration. The only thing I don't know there is delta t. So the final velocity is 0, the initial velocity is 7.07, acceleration is -10 times delta t. So -7.07 equals -10 times delta t. And so I end up with 0.707 seconds is how long it's in the air. So let's go back and put that in, 0.707. and this is in seconds. Now, there's a couple ways I can actually remember what we're looking for. We're looking for just the VI right here. We're not looking for VIX or anything like that. So I should have enough actually to solve this. If I look at the triangle I'm dealing with, I'm just going to redraw the triangle here. Here's the VIX, here's the VIY, and we know the angle is 30. So if this is 30 degrees, and my initial y velocity 7.07, I'm looking for that VI. So this just becomes a trig problem. I know that this is the opposite side, this is the hypotenuse, and I can use trig to solve for VI. So that's just going to be the sine of 30 is equal to the opposite, 7.07, times the over the hypotenuse, which is VI. And you should get 14.14 when you solve for VI there. You could also use special rights in this case. Since it's a 30, 60, 90, we know that if you double the opposite, you get the hypotenuse there. So that is the minimum speed required, 14.14 meters per second. All right. The other way you could have done it is you could have solved for the VIX right here. We know that 20 meters, it goes 20 meters in 0.707 seconds, and that would give you your VIX, and then use Pythagorean theorem if you want it. It's just easier to use trig in this case. All right. Hope that helps.